Okay, so for the final video, now that you've run all of your tests, you've reported out on all of your findings, I would look at what alpha level you did your test on, which was probably a 0.05 alpha level, and just see if I changed that alpha level, would it make my argument more convincing? By changing this alpha level, it doesn't change any of the statistics you've computed. It may just change what the conclusion or the outcome of your test was. So for example, let's say I came out with a p-value of 0.86 from my test. So if I was testing at a 0.05 alpha level, then that's greater than 0.05. We would fail to reject the null hypothesis, which means we did not have evidence of the alternative that we were trying to show. Now, if I tried to adjust this alpha level a little bit, this one was done at a 95% confidence level. If I wanted to try to up my confidence and make it 99% confidence instead, then my alpha level would be the other part of 100%. So I would be comparing this 0.86 to 0.01 alpha level. It's still greater than, it doesn't change my outcome at all. We still fail to reject the null hypothesis. We still do not have evidence. So since it doesn't change my results, it would be a lot more convincing to your audience to be 99% confident than it would be to be 95% confident. So I would probably change my alpha level, even though it's not going to change any of my work. It just sounds better for me to be more confident in what I'm doing in my study, okay? Now, if my p-value was 0.03, so if I did a 95% confidence level, and I tested to see how that 0.03 compared to the alpha level of 0.05, which matches up with my 95% confidence level, then 0.03 would be less than my alpha level, which means I would reject the null hypothesis, and it would show that I do have evidence of what I'm trying to show, okay? If I were to up my confidence level on this, if I wanted to show my audience that I'm really 99% confident, not just 95, then my alpha level changes to the other 1%, which is out of 100%. So when I compare 0.03 to 0.01, it's not less than anymore. Now 0.03 is greater than 0.01. And now I have to fail to reject the null hypothesis. And now I do not have evidence of this alternative that I'm trying to show. Now, it just depends what your study is. Maybe you don't want to see it change. Maybe you are trying to convince people that it's changed. So it just depends on what you want to relay to your audience as to which one of these confidence levels you would want to pick. Okay, but in this case where that value is so close to 0.05, changing that confidence level could change the results of what that test is. Another final example, if I had a p-value of 0, if I do that 95, standard confidence level and compare that 0 to the 0.05 alpha level, 0 is less than 0.05, so we would reject the null hypothesis, and we would have evidence of our alternative. So if I change that to a 99% confidence level and change that alpha level to 0.01, 0 is still less than 0.01. That gives me the same result. So again, if it's not going to change the result of my test, then I'm probably going to want to go with the 99% confidence level and be more assured of that. With a p-value of 0, I could even go to a 99.9% confidence level and compare that to 0.001 and still get the same result. So we can be very confident. The lower that p-value, the more confident we can be of that evidence of that alternative. So use that idea to make your arguments more convincing to your audience.